Hello and welcome to Hacking Exposed, Learning from the Adversaries series. Today we're going to take a look inside the Microsoft Exchange Proxy Logon hack. Welcome, my name is Brian Robison. I'm Chief Evangelist here at BlackBerry. So today's agenda is pretty simple. In past Hacking Exposed episodes, we have talked about fileless attacks and fileless malware. So we're going to re-look at that, and we're going to talk about how these attacks actually work when we are presented with zero-day exploits and attacks, and we're going to take a look at remote code execution as a vector of attack. And then we're also going to take a look at some of the details inside the Microsoft Exchange proxy logon hacks that have been happening recently out in the world. And lastly, we're actually going to spend time in the lab. I've actually got a version of this actually working. So I will be able to show you how the hack works and even what we can do with it once the machine has been exploited. So I think this is going to be a lot of fun, and I really hope that you enjoy this Hacking Exposed episode. So to begin, we're going to take a look at what are fileless attacks. And fileless attacks are attacks that are memory resident, they can be script based, they can exploit resources, even system registry, and things like that. But in general, they are not file free attacks. And I've talked about this again before. A lot of these attacks begin with weaponized attachments or weaponized download documents and things like that exploit the system, exploit the user, and are the main entrance into the system for an attack. So again, they're not necessarily file-free attacks. That's not what we mean by fileless attacks. However, what we really mean is that they are not executable based in general. So normal malware attack, we're going to try to drop an exe on a box or something like that and try to get the user to run it. Might be ransomware, might be some rootkit, might be something else. But generally, fileless attacks do not use an executable as their first line. These are, again, a lot of times, in the vast majority of them, they're script based from weaponized documents. Now, the goal of a fileless attack is to remain fileless, so we stay in memory. Writing files to disks triggers other security tools, other elements to look at these new files. So our goal would be to not write any files to disk. However, in some cases, the second or third stage of the attacks do actually write files to disk. But again, trying to stay away from those executable files. Fileless attacks are most generally used as the initial phase. So the first phase of an attack against an organization can be a fileless attack, like I said, whether it's a weaponized document or even if it is some sort of exploit that's attacking the environment. Once the initial phase has been established, persistence has been established, the attackers are then going to generally live off the land and use existing trusted tools to do their work on behalf of them. And that makes it easy for them because, again, we're not introducing new executables into the environment, which would trigger things like application control or blacklisting or whitelisting, those types of environments. So if we can use the systems against themselves, then we're going to be in a much better place to remain as hidden as possible for as long as possible. Now, sometimes we do run into what's called a zero-day exploit-based attack, which really doesn't require an attacker to do anything or even a victim to be running any code on behalf of the attacker. It's not something that we need to worry about double clicking on an attachment and opening it and enabling macros and those other types of fileless attacks. So, in fact, today we're going to explore this element of the zero-day exploit-based attack. In previous Hacking Exposed episodes, we've talked about the weaponized documents and script-based attacks, but today we're focusing on the zero-day exploit-based types of attacks. So let's start by talking about what is a zero day, right? And we need to define this in the terms of something called a vulnerability timeline. And I put together a quick visual just to understand so that everybody can have a basic understanding of kind of what we're talking about when we're looking at a 0 day. Now, with a 0 day, there is some software that's written, it's out there in the world, it has a flaw in it, hopefully unknown to the original authors, but maybe sometimes people put stuff in there. But generally, this is something that is unknown. Now, there's an actor, hopefully it's a researcher or somebody else who has good intentions, identifies that flaw. And when they identify that flaw, if they are reporting responsibly, they would inform the vendor of the software that there's a flaw, and the vendor could then go and fix it. However, in a 0 day attack, once this flaw has been identified, we then end up with a situation where the actor, again, hopefully maybe it's a researcher, creates an exploit of that flaw to produce a result. And that result is usually something called a boom, or what I call a boom. And that is the software is done something based upon the flaw and the exploit that was created by the actor to result in giving me access to the system or giving that actor access to the system. So the boom occurs, and this is the reason it's called 0 days because this all occurs before anyone realizes it, before humans have a chance to identify and see this. So this is why the industry calls this a 0 day. Now, after this usually occurs, now we have, this attack, if you will, a 0 day attack becomes known to the world. Developer and the vendor rush to fix it and patch it, etc. And once it's has a CVE, common vulnerability identifier, then it's no longer considered a 0 day because the world knows about it. So everything up to the boom is kind of what is considered a 0 day. So let's take a look at the 0 day in the frame of, or the vulnerability timeline in the frame of the recent Microsoft Exchange proxy logon attacks that have been happening. So if we look at software written with an unknown flaw, right? We have Microsoft Exchange, extremely popular email calendaring, PIM, all the cool stuff that Exchange has been doing for a very long time. And according to Microsoft, only the on premises versions of Exchange Server 2013, 16, and 19 were vulnerable. And that is even if you had the latest available patches applied to both the Exchange Server and the underlying Windows Server environment. So this is basically this is what is out there in the world. Even if you are the latest and greatest and up to date on your patches and everything else, this software is sitting out there with this known vulnerability. Now, in early December and even into January of this year, researchers out there began to find multiple bugs in Exchange and specifically the Outlook web access portion of it. So this requires the Exchange server to be, available via the internet, and people are using the Outlook web access as an email client. The researchers from DevCore actually found there were multiple bugs in that. And once they actually chained them together into a set of multiple commands, they realized that this resulted in something called RCE, or remote code execution. We're going to talk about RCE in just a few moments. But essentially, these researchers realized that this is a boom type of moment because they were able to execute code on the system without requiring any sort of authentication into that system. They weren't authorized. So if we fast forward a bit to January, and this is when Microsoft gets notified, their CVEs get created based upon the researchers from DevCore, and all of these types of things happen. However, normally these things occur in a sequential time. However, in this case, we actually go back 2 days. Um, Responding company called Velocity out there reports that they have seen evidence of attacks of these exploits even before Microsoft gets notified. And this is a very interesting element that's happening here is that, potentially other people have also figured out that these bugs have existed and begin to attack the environment. And in February, when Microsoft essentially began to get the industry ready for the patches coming in March, there was a huge rash of these attacks that were seen out in the world. So in the January timeframe, it was very quiet with this. There were a few of these things that were out there, but it wasn't going rampant until essentially people began to learn that Microsoft was going to patch these vulnerabilities, and that's why in late February and early March of this year, the world began to see an explosion in threat actors actually searching for and uncovering and exploiting these bugs. Now, in March, obviously, we have, Microsoft has attributed some of the early attacks to an unknown threat actor, and they named it HAFNIUM. And so you may know this from the news as HAFNIUM or Proxy Logon. And Microsoft then readied their patches. They've released multiple series of remediation tools to allow Exchange users to scan their environments to double check, make sure if they have been exploited or if they haven't, how to remediate, and even supporting patches for unsupported versions of Microsoft Exchange. And as of now, there's a pretty good vast majority of these Exchange servers that have been patched, but this is still an issue. And realistically, this is still an issue even if your Exchange server is not exposed to the internet. Because if I get into your environment with some other machine, I can then use this same type of attack to attack your internal Exchange server and exploit and gain access to the system that way. Now, the other thing that has happened in March is public proof of concepts became available. And controversial, whether we want to have, proof of concepts available out there for the script kiddies to take on and be able to do or not. Don't want to debate that here, but there were some proof of concepts that were made available and were then later removed due to who knows what real reason, but due to terms and conditions, etc. But there is code out there today that is readily available. And if you have any sort of rudimentary skills, you can make them actually work. So this is kind of where the state of the world is right now with this environment. So let's back up just a fuzz and talk about what is remote code execution. So we talked about the timeline of the vulnerability itself, and now let's explore what can I do once this vulnerability gets exploited? What can I do? Well, a remote execution is essentially it's a type of, here's another security acronym for you, ACE, which means is simply arbitrary code execution, which is essentially the attacker's ability to execute an arbitrary command or code on a target. And the R essentially means remote. So it's not that difficult to understand, but this means that an attacker can reach out and poke you and gain control of your system without you having to give them authorization, without them having to crack your credentials, without them having to get an inside social engineered person to execute code, any of that. They can reach out and just touch you just because you have a server that's on the internet. And to me, this is probably one of the scariest type of situations that occur because we're all trying to get our business done and we're running these servers that are putting out these services. And if a hacker can get into my environment based upon simply me trying to just do my business and unknown to me, that's kind of a scary situation. So very similar to the vulnerability timeline, let's look at the timeline of remote code execution. So, generally, is something that's going to occur once that threat actor or researcher has identified the flaw. Maybe they've even developed an exploit. They're going to recon. They're going to look for servers, services, applications, web apps, etc., that are vulnerable to their attack that they have researched and created an exploit for. So they're going to look around for these things and identify and find them if they're out there on the internet. Then they're going to issue their exploit. They're actually going to create this exploit, that vulnerability that's exposed. And then they're going to go on to doing things like establishing persistence in the environment. In a lot of the cases, for example, with the proxy logon attacks, they're establishing persistence so they can come back and do something a little bit later, maybe. So the idea is you recon and exploit as fast as you can, get as many of these in your, quote, network, if you will, as you can, and then come back later and then do whatever you're going to do. And that's where you get into doing things like, okay, now we're going to look around inside the network. We're going to look around inside the system that we have exploited, and we're going to look locally on the host. We're going to look around the network. We're going to see what is sitting next to it, parallel to it, or in the same network. And we can begin moving laterally. We can begin doing fun things inside the environment to gain more information about our victim, essentially our targets. And usually the last thing that's going to happen is we're then going to, once we've basically have this in, we know we're hidden, we have the ability to get in anytime we want. We're then going to exfiltrate some data. We're going to nuke the environment. Maybe we're going to drop some ransomware or whatever. But that's our goal, right? Our goal is to essentially get in there and get access to the system, or get your domain admin credentials as an example, or we're going to monetize this by dropping some ransomware. Okay, so if we take a look at the remote code execution along the lines of the recent Exchange proxy logon attacks, we look at, in our recon phase, our goal again is to find those vulnerable servers that are out there. We're going to use scripts and tools to scour the internet for, one, an exposed Exchange Outlook web access server, and we're going to make sure it's the right version so that we can exploit it. And we're then even going to have other tools that are going to come back and test those Exchange servers for common valid accounts, email addresses essentially. And we can do this using the auto discover feature. So this attack does require a valid email account, or a user account, but we don't need to have the password. So we basically just need to test the server to see if things like administrator at domain.com, or test user, or Bob, or something like that comes back and says, this is a valid email address on this server. And then we now have a list of vulnerable servers, and we have a list of valid accounts that we can then use in our boom phase. So that's what we do, is we come back now with the boom phase and we exploit it using the information that we got from our initial recon of the internet. And the way this would work, again, it's a script or a program that executes the exploit, does the remote code execution, if you will, and potentially gives us even privilege escalation. Sometimes a remote code execution doesn't necessarily give you the highest level of permissions. Maybe it gives you permissions of a specific user. But in the case of the Exchange proxy logon attack, we actually end up landing on the server with the permissions of the Exchange server software itself, which is again one of the parts of this that is the most dangerous. So establishing a web shell, or establishing persistence, in this case, most of the cases we're using a web shell to establish a command and control infrastructure essentially into the environment. So I can now issue commands through the environment, almost like if I were sitting at a command prompt on the box. But again, this is somewhat dangerous. This is probably one of the most dangerous, because essentially the attacker now has a command line on our Exchange server without us knowing that they're there, and without and at the permissions of the Exchange server, which are really some of the highest privileges within the Microsoft Exchange and Active Directory type of environment. Then, the attacker, once they have this web shell on the system, they can then go ahead and do some discovery around the environment. They can look at, trying to find information about the system, the users, other accounts, other things on the network. They can begin looking around and gathering information on how they want to proceed with their attack, or they can finally, use living off the land tools to do things, to exfiltrate data, maybe dump LSAS if you want to get your domain creds, for example, drop some ransomware, do whatever they're going to do. But this is essentially the order of execution, and the timeline that this attack is basically exempling out in the world today. And it's a dangerous one. It really is, because nobody could see this one coming, really. And before anybody really knew about it, it was being exploited, and it could be in the tens of thousands or even more of these exchange servers have actually been owned out there in the real world. Okay, so that's it for theory. And I like theory, but theory doesn't make it reality. And so now what we're going to do is we're going to switch into the demonstration lab, and I'm actually going to show you a a modified proof of concept of this actually working against a real world exchange server. And I think you're going to enjoy the demonstration portion of this. So let's switch over to the demonstration lab and get going. All right, now that we're in the lab, let's take a look at some of the systems that we have here. As with other Hacking Exposed, I keep my attacker systems over here on the left, and I've got basically a basic Linux box. This happens to be a Kali build, but this could run from just about anything. And I've got this box set up, and this is going to be my attacker, if you will. This is what's going to be executing code against the Exchange server. The Exchange server is over here on the right-hand side, and it's very easy to kind of take a look and see, what this machine has in it, everything that's it's installed. And I happen to have a Exchange Server 2016 running the cumulative update 17 in it. I did recently install that version, but this is not the latest cumulative update, and it does not include the essentially the fixes for the proxy logon HAFNIUM attack. So this is all set up and running. It's got Outlook web access. This server is not internet facing, so it's in an internal network. But in all basic respects, it is a full-on Exchange server, and it is ready to be attacked. Now, the way is that this attack actually works, and before I didn't grab the proof of concept, the one that was removed from GitHub, but I did grab another one. And right now, I'm not putting any URLs on the screen or anything about where I got this, just because this kind of is an attack that's happening out there now, and we don't want to necessarily enable everybody in the world. But it did take a little bit of work, not a lot, to get it to actually work and talk to the Exchange server and actually do some of the exploits. So I'm going to run you through kind of how I set this up and what some of the results are going to be and what it looks like on the Exchange side of what's going to happen. So the first thing that we're going to look at is we're going to look at the specific directory that controls or that contains the Outlook web access authorized ASPX pages, essentially. And these are the ones that the server essentially comes with. And you can see here, update 17 did update some of the files in here, but all of the ASPX files are essentially the ones that ship with Exchange by default and have been on this machine for quite some time. Now, Exchange, as you know, runs multiple um, IIS processes as web servers, websites, and things like that in the background. And I bring up my task manager, and I look at the processes that are running, and I sort them by CPU, because one of the interesting things about this attack is the RCE that drops the web shell on the box actually doesn't really do anything yet. But as you drop a new ASPX into this directory, what that and you call the same attack again, what it does is it causes the exchange server to reinitialize essentially all of the ASPXs. So we're going to see a pretty good bump in CPU utilization over here, as you'll see all of these W3 WP processes will kind of peg, and that's essentially one of the kind of symptoms you might see. Is it almost looks like a reset of IIS in the background. That's kind of what's actually happening. Okay, so I have a Python script that's on this box, and um, the proof of concept. I've actually got two of these. We're going to look at version of the original, and then we're going to look at an updated version in a moment. But the original one of these um, is basically the proof of concept that I located. And what it's going to do is it's going to create this shell, the web shell. It's called to call it test11.aspx file. And then if we scroll down, we're going to actually get down to where we can issue the command on the Exchange server. So here we can see test11 ASPX, and we're going to send the who am I command against the Exchange server and output that back to our attacker. So it's quite simple to run this. However, the commands are a little bit lengthy, so I've created myself a nice cheat sheet of cut and pastes. So we're going to take a look at this, and we'll do this in order. But basically, we're going to tell Python to execute this script, and we have to point it to a specific Exchange server, and this happens to be the name of the Exchange server on the right. And we have to give it a valid account that exists on that server. So again, this goes back to that recon phase of looking out there on the internet and finding valid email addresses that exist on the Exchange server. And so we just need to have one of those that actually comes back with a positive result. So we know this account exists on the system because it's my account and I know it's there. And so we're just going to execute this script and see what happens. So it's going to attach to the Exchange environment, and it's going to then drop that web shell out onto the system. And we don't get any output from it yet. However, we do see the test11.aspx file sitting on the box. And again, like I said before, the first thing that it does is it drops that web shell on the box, and then you'll see loading of processes of some of the W3 WP processes essentially as they pick up that change and now kind of queue up for loading that new web component that exists inside. So the way to make this run, the way that to get the output is to run the command again, the same command that we ran before. And this time it's going to start talking to the web shell, and we're actually going to get back the permissions, the output of that who am I command. And as you can see here, we have basically the highest authority on the system. We are coming in as the system permissions on the box, and we can begin utilizing this to execute commands with that level of permissions. So that's essentially how the basic attack works. What I'm going to do now is I'm actually going to delete this ASPX file, and we'll throw it away and empty the recycle bin. And so, this again, this is just an example of a researcher's proof of concept that is able to actually attach and trigger the chain of exploits that result in, this command here, essentially being able to execute who am I. Okay, so now that we understand kind of the basics, let's take a look at what we could do with this. Now, one of the things we could do with this is we could replace this command in this script to do something else, like download and install a command and control, like the one that I always love to use in my Hacking Exposed demonstrations from Dave Kennedy at Trusted Sec. I love using Trevor C2 because it hides in plain sight. Uh, but with this one, I decided to take a little bit of a different approach. And I said, okay, what happens if I take this proof of concept and modify it into its own C2? And that's essentially what I have done. So let's take a look at the V2 version of this. Again, 99% of this thing is going to be basically the same, except for I'm going to pull from the command line a third argument, which is essentially the command I'm going to issue. I've also changed the name of the ASPX so that we can see a visual difference on what's actually happening. And then at the bottom of the file, instead of entering just the who am I'm actually going to go ahead and issue a command that I am in control of and get the output of that command dump back to me. So it's not necessarily an interactive shell, so I can't run tools that need me to answer questions, but as long as I can enter them in a single individual command line, then I'm actually going to be in really good shape with this. So let's go ahead and exploit the server. Again, I have to drop the web shell using the remote code execution exploit, and then we're going to watch IIS essentially reset and reload and load that ASPX file, and then I can begin exploiting it. So we're going to do basically a repeat of the proof of concept with my own commands. And that's what we're going to use this for. So basically, again, we're going to execute, this time we're going to execute V2 of the Python script, same target, same email address, but this time we have the ability to just type in whatever command we want to issue. So I'm going to go ahead and use the who am I as a good example. And I've also fixed some of the formatting things and the output and made it look a little bit better from the original script in this version, so it's a little bit easier to follow. So once again, we're going to issue the running of the command who am I, and of course we do get the fail to write shell, which is again I fixed some of the output of this, but as you can see that that new ASPX file has now appeared on the Exchange server, and you'll see again the reloading of some of the IIS processes that are required for this to take effect. Now, we're just going to rerun the same command again, and hopefully this time we get the output of who am I is NT authority system. So once again, we've actually, exploited the server, but now we have a much more interesting type of environment where literally I can start issuing any command that I want to issue. And I can do other things like, give me the output of net accounts, for example. So we can even try that. We'll go in here and we'll do, show me, I'll put this in parens, show me the output of net accounts. And boom, all of a sudden you see, hey, look at there. There's your output of net accounts. We're beginning to discover, we're beginning to do recon about information on this system coming in as NT authority system and giving us an output of very useful type of commands. And yes, this little modified version does work as a kind of a C2 where we're issuing commands and we're able to get responses. So, as a very good example here, one of the things that I would like to get off of this machine are domain creds. Can we actually get domain creds? And a way to do that is to essentially dump the memory of the LSAS process and run it through a tool like Mimikatz or PyPyCats or something like that that is designed to essentially dig through that encrypted file and spit out in clear text some of that stuff that exists in memory. So if I wanted to dump LSAS manually, I could just find the process in Task Manager, right click on it, and choose create a dump file of its memory from Task Manager. It's really easy to do. But I don't have access to Task Manager from remote, right? So I'm trying to do everything I can from our remote attacker. So there's several different ways to do this. There are some living off the land techniques. If you're trying to use like invoke mimikatz from PowerSploit, some of the newer operating systems don't really work that well. But one that does work really well is procdump from Microsoft's own sysinternals kit. And sometimes, IT will already have, tools like psexec or procdump already on these boxes that you can use. Um, in this case, I don't already have that tool set installed, so I basically need to, quote, install it. And the good thing about these tools is that they're designed to be, deployed out to environments and run without having to run installers. So it also provides kind of a way to remain hidden. So I want to drop, the file onto the box and then actually begin to use it. Now, yes, this is dropping an exe on the box, but in most cases, in most security tools that are out there and most IT environments, again, these tools are extremely useful and will either already maybe exist or they will be whitelisted by security products and other technologies. So, um, what I'm going to do is I'm going to drop this new exe because this machine is running IIS. It's got this directory called inetpub, which is where the basic kind of default web pages and things live. And I just chose, I want to just drop the procdump exe into this directory. Now, again, I don't necessarily, want to raise too much suspicion on, firing up web browsers or PowerShell even or other tools. So let's use the, infamous cert util to go grab and download, um, you know, proc dump essentially to the host. So I'm going to use my V2 again, same target, same email account, and I'm going to use the cert utility that exists in the Windows system. It's already trusted. It's part of the OS. Cert util is a great example of a live off the land binary that I can use. It's not something new. I can drop it out on the system, or I can use it without creating, a new exe. So what it's going to do then is it's going to basically use cert util to download procdump exe, and we're going to save it in the inetpub directory, which is right here, as pd.exe. So we'll execute this. And you'll see here the output of the command is that it completed successfully. And sure enough, we ended up getting a brand new copy of the sysinternals process dump utility from Microsoft. And we dropped it into the inet pub directory. So now what we're going to do is we're going to use procdump to create a memory dump of the actual LSAS process that we can then exfiltrate the dump file off and then look for our passwords and things in that. So what we're going to do is we're going to take a look at this folder now. So this is system32 inetserv. And when we execute procdump against LSAS, it's basically going to dump the LSAS memory into a file in this directory. And I have it sorted by date modified. So we should see that brand new file appear right here at the top of the list. So let's go ahead and get our procdump going. And again, right, same script, same target. We're going to run procdump. We have to do a few command line switches to accept the EULA, etc. We're going to dump. We're going to do a mini dump out of the LSAS process, and we're just going to save it in essentially the home directory of the process that we're coming in as, which happens to be inetserv. And so execute that command. And you'll see basically, yep, we got the dump. We initiated out the dump, and sure enough, we see a couple of process dump files that are located in this directory. So we've now created a memory dump of the LSAS process, and let's go ahead and get those processes off of the host. So, or those files off of the host. So to do that, I'm just going to spin up a real simple little FTP server. And we're going to drop that FTP server down here at the bottom. And again, we're just doing this all in Python from our Kali Linux box. And we're just going to have an FTP server listening. And then we're going to instruct the attacker to essentially FTP that file over to the listening FTP server. So we're going to exfiltrate the data. Now, this command is quite long and somewhat complex, but it basically works like this. Again, same script, same target, same email account. We're going to launch a brand new command exe. We're not using PowerShell because a lot of tools are going to look for PowerShell spinning up, but we're going to use command exe. We're going to have FTP open a session to our server over here. And we're going to do things like login is anonymous, our password is anonymous. We're going to issue the FTP binary command so we make sure we get the binary data of the file. We're going to turn off our prompting, and we're going to input our LSAS DMP file. Okay, now you'll notice over here that we've got two files. We've got an LSAS DMP and an LSAS-1 DMP. So we're going to issue this command twice and get both dump files because we might actually have a difference in the data that's in there. So we'll just issue them kind of back to back here. So we will issue the command, and you'll see here basically, again, we're running this kind of in verbose mode. So we're going to see the command. We got our LSAS dump file. We stored it on the system, and you can see here the information from the server coming back, and we have our LSAS dump file. Now, like I said before, we're going to issue the second command and grab that secondary file just because we want to make sure we grab it as fast as we can. And so we're going to go ahead and get both of those files. And as you can see here, we now have both of those files on our attacker box. They still exist over here. We could have issued, some commands to delete the dump files to try to maintain our stealthiness if we wanted, but we're just going to go ahead and leave them there because right now we're not really concerned with that. Okay, so what can we do with a dump file? Well, let's dump the information out of that file into a text file. And we're going to use the tool called PyPyCats, or some people call it puppy cats or whatever. But this is basically a Python implementation of the Mimikatz tool. And we're going to look through the mini dump for LSA information, essentially logon information within the dump file. And we're going to dump, or again, we're going to do this twice because we want to make sure we get both of the dump files. And then we're going to basically dump this information out into a text file where we can then scour that for the actual credentials of the environment. So we issue the command, and it looks like this one didn't quite have the right stuff in it that we're looking for. So hopefully maybe we get that out of the -1 dump. And yes, this one looks better. So I don't know why, again, dealing with memory dumps is kind of a rudimentary thing, but if you get a bunch of errors when you run PyPyCats, most likely it's not finding in that dump file what it needs to search for, the LSAS information. But we do have it. We didn't get any errors from the -1 file, so we're going to look at the output1.txt file. And this contains clear text information of the actual dump. And if we look somewhere around line 249, I think is probably about where it's going to be in here. Oh, yep, sure enough, line 249 actually contains the domain administrator creds for this Exchange and Active Directory environment. So that is a massive type of exfiltration and data gathering that we are able to obtain directly from the Exchange server without knowing any sort of creds, and utilizing the Microsoft Exchange Proxy Logon, HAFNIUM vulnerabilities. We're actually able to get some of those very, very critical credentials off of that host. So cool. Awesome. We've got our attack working, and let's go ahead and switch back very, very quickly and close out our session. Okay, we are back from demonstration. And just lastly, I really hope you guys enjoyed this session. Thank you very much for attending this Hacking Exposed session, talking about looking at the insides of the Microsoft Exchange Proxy Logon HAFNIUM attack. I appreciate your time today. And if you'd like to reach out to me, my contact information is right here on the screen. Would love to speak with you about these or other Hacking Exposed episodes. Thank you very much.